Density is the relationship between an object's mass and its overall volume. Density is the relationship between the mass of a given figure and the space that that figure takes up, given by its volume. I have what type of shape in my hand right now? A cone, right? The cone is made up of kind of wood, right? So the density of this cone is the mass of the wood divided by the volume of the cone. How much weight this wood has in terms of divided by how much space enclosed by the cone itself, enclosed by the given figure here, this cone. Mass divided by volume, the mass in terms of the volume. When I think of density, I think about the weight of the object in terms of the volume or space it's taking up. I'm trying to shove this much weight into this much space. That's given by its density. The weight of the wood in terms of how much space that wood is enclosed by. Okay? Now let me change the game here for a minute. Say I have this same cone, this same size cone, but now it's not made of wood anymore, it's made of steel. What's going to have a higher density? The cone of wood or the cone of steel? Steel, right? Because wouldn't steel weigh more than wood? I have a heavier object with the same volume. I'm putting more weight into the same space, so it's going to increase the overall density. As a helpful formula, density is the mass in terms of the volume. I'm putting this much weight into this much space. That's a description of what's called the density of an object. Weight in terms of the volume, mass in terms of the space, enclosed by a figure. We can also describe mass in terms of the density and the volume. This equation, this formula, is to solve for the density. I can also solve for the mass in terms of the mass by multiplying both sides by volume. I'm multiplying and dividing by volume at the same time. So that. Now I have the mass equal to
Lily Thompson to the high school office. Lily Thompson to the high school office.
density times volume, which you can see right here. Similarly, if I solve for mass, mass is equal to the density of an object times the volume of the object. Density is mass divided by volume. Or for your work here today and tomorrow. Let's try a couple applications of that. First up, talk about population density. The city limits of Van Meter measure 1.62 by 1.45 miles. You're within town. 1.62 miles by 1.45 miles is the city limits of Van Meter. Overall, the city's population is 1,292 residents. What is the population density of Van Meter? How many people live in every single square kilometer in town? That's what we're trying to describe. How many people are there per square kilometer? Let's, mile, I'm sorry, I said kilometer out of that mile, pardon me. So let me draw here, shape of the town. 1.62 miles, 1.45 miles. Here for Van Meter. Density is going to describe the people per square mile. How many people live in this much area or this much space. How many people live in Van Meter?
1,000.
Okay, let's get rid of the question. What's the land area of Van Meter? How much space does Van Meter take up? I'm not going to figure out that now. What is the area of our town? How much space does Van Meter take up? I know it's 1.62 miles by 1.45 miles here. How do you get that?
Oh, I multiplied it here.
Yeah, and then just find the area of the city limits of Van Meter. 1.62 times 1.45 should be how many square miles Van Meter takes up. Area is 1.62 miles times 1.45 miles. And once again, Tommy, you said that was what? 2.349 what? Miles square miles. How many people live in that area? Once again, how many people are there here in town? How many people live in that area? What's the population of Van Meter, Destiny? Up on the board here. So to find the density, I have this many people living in this amount of area. Would I want to multiply these two numbers or divide these two numbers? Density would be the number of people living in a certain amount of area. So we're going to divide 192 people divided by 2.349 square miles. This many people living in this space. The density of people per square mile will be how many? Find those two, Kara, what do you get? This is 1,292 divided by 2.349 square miles. Say it. 550 or 525? I didn't quite catch that right. 50. So the population density here in Van Meter is 550 what? What do you think the label is going to be, Trusty?
People per square miles.
For every 1 square mile, there would live approximately 550 people. Per every 1 square mile, live approximately 550 people. I live in Des Moines. Which do you think would have a larger population density? The city of Van Meter or the city of Des Moines? Which would have a larger density of people? Des Moines or Van Meter? Or Van Meter, I'm here in Des Moines. Does anybody think one or the other? It's also a bigger area too. Which would have more people per square mile? Here in Van Meter or Des Moines? Let's look it up. Let me get my AirPlay hooked back up again. It has more people, but it also has a larger area of land, doesn't it? Does it have enough land to cancel out having that many people? I pull up the Wikipedia page for Des Moines. I bet it has these values given for us here. Let's see, Des Moines has a land area of 88.18 square miles with a population of 203,433, as you see up here on the television. 90.66 square miles with a population of 203,433 for a density of just under 2,500 people per square mile. 2,429.46 people for every square mile. Why would that make sense? That Des Moines has a much larger population density than you would see here in Van Meter.
It's less than
Density would be like how compact these people are living. Where are you going to see more people living closer together? Here in Van Meter or here in Des Moines? What do you think, Sylvie? Why does it make sense that Des Moines has a larger population? Where do more people live closer together? Des Moines. Okay, I mean, Des Moines, right? I live in Des Moines. I can almost reach across my window and shake my neighbor's hand when we're living in the same house, right? I can reach across the alley. I can shake his hand. He's living in his house. I'm living in mine. The houses are so close together. Van Meter is a little bit more spread out.
They should try to embrace it.
There's almost 5 times as many people that live in the same square mile in Des Moines that live in Van Meter. There's about 550 people per square mile in Van Meter, and almost 2,500 people live within every square mile in Des Moines. There's 5 times as many people living in the same area when I compare the two together. It's much more dense or crowded in Des Moines than it would be in Van Meter. More people living closer together. It's a good application of density when it comes to area. Let's try the same thing for volume. Another example just to the right. Let's read through this and tell me what's missing. What do I have to find first? You're going to buy a prism-shaped water tank with a base area of 1.3 square meters like you're seeing below in the picture right here. After purchasing 6 goldfish at the pet store, the owner recommends their density in the tank is no more than 4 fish per cubic meter. I can't have that many fish living in too small of a tank, right? They might not survive. You know, too many fish in too small of a tank, overcrowding and might die. How high should you fill the tank with water? I want to know how much water to put in the tank so that the fish have enough water to live and not die.
Well, why don't you just fill it up to the max that you think you can?
Okay, could do that.
What's the minimum?
But I would also have to keep cleaning and changing and filling up that same water every single time. Could I get away with using less water in the tank? What amount of information is missing first? What do I have to know before I can answer that question? Read that more times. Tell me, what do I have to find first before I can answer this question? Okay, Max, what do I have to know first? That's what we're going to figure out in the next step, but I have to know something first. I am missing the height of the water in the tank, the height of the prism itself, sure. What do I have to know first before I can find that missing height of the water? Second, the volume. What is the volume of water that these fish can safely live within? So that the fish have enough space to swim around. So let's find that minimum volume first, and then max, I'm going to find the height of the water, okay? I need to know how much volume the fish can live within before I can answer the height of the water to put in. Find the minimum volume of water. How many fish do we buy? How many fish do we buy, Emma? 6. So we've got 6 fish. What is the density that I have to hit? I have to have no more than how many fish per cubic meter? 4. So to figure out the minimum volume that those 6 fish can live within, would I want to multiply 6 and 4 or divide 6 by 4?
Divide by 6 by 4.
Divide 6 by 4. Why?
because that's the density divided by the.
Sure. How many times can 4 fish per cubic centimeter divide into the 6 fish I purchased? That's going to convert this into a unit of volume that these 6 fish have to live within. If that doesn't make sense, think about this as unit conversion. 6 fish, when I multiply by 1 cubic centimeter for every 4 fish, what labels cancel out? The fish. I'm canceling out the labels of fish, the units per fish, leaving me that cubic centimeter volume label left over. 6 divided by 4, or 6 times 1 divided by 4, converts the number of fish to the volume that those 6 fish can live within. What's 6 divided by 4?
2.5.
Okay. So I have to have at least 1.5 cubic centimeters of water so that the fish have enough space to swim around. Got that part figured out first. Put at least 1.5 cubic centimeters of water in the tank for my 6 fish. Now, like Max said, let's find the height of the water, the height of the prism. Find the height of the water. Since it's a prism, Destiny, how do you find the volume of the prism? I need that formula. Prism. Base times height, the area of the base times the height. The volume of our fish tank is the base area of the tank times the height of the water. We're trying to find the missing height when it has what volume? What's the volume of the water in the tank supposed to be here, Molly? What's the volume of water I have to put into the tank? 1.5. So let's substitute that in for V. Perfect. I was given what base area then, Cam? What's the base area? 1.3. So B is 1.3. What height of water times the base area of 1.3 makes our overall volume of 1.5 cubic centimeters? You just divide, right? What times 1.3 makes 1.5? Divide by 1.3 to find out. You said what again? So we need at least fill up to a height of at least 1.15 meters. So I forgot at least. Fill up to a height of at least 1.15 meters of water. Step 1. What is the minimum amount of volume that these fish can safely live within? I have 6 fish with at least with no more than 4 fish per cubic centimeter. By dividing 6 by 4, I knew how many cubic centimeters of water that these fish could safely live within. Once I knew the minimum volume, I was able to use the volume formula that Destiny gave me, work backwards and solve for the missing height.